Okay, so now we're still on the final exam review for College Math 2. And so we worked on exponents, factory polynomials, and now we're going to solve polynomial equations that we want to factor. In the first example, they're not factored, but we want to be able to use this factoring skill so that we're able to get our polynomial in factored form, set it to 0, and factor to solve. So we're going to start off with the first one where it's kind of like a level 1 game where it's already factored. So what we're going to use is this idea: if we have two factors that when multiplied together is equal to 0, then either A is equal to 0 or B is equal to 0. So we're going to use that idea and we're going to look at our factored form. We're going to say, okay, well, we have a factored form. We're going to say then x minus 3 is equal to 0, or we're going to say 4x plus 1 is equal to 0. And then we're going to proceed to solve each equation. So we would just add 3 to both sides here, and we would get x is equal to 0 plus 3. We would get 3. And then for the second one, we would then, of course, subtract 1 from the left and the right. So that would give us 4x is equal to negative 1. And then we would divide both sides by 4, and that would give us x is equal to negative 1/4. And that would give us our two solutions to the quadratic equation in factored form. Okay, so our two solutions are x is x, and we could say it fancy if we wanted to. X is equal to 3 and negative 1/4. Maybe we won't take quite so much time to solve it like that, but we want to make sure that we include both of our solutions in our final statement. Okay, so now the next problem, we don't have it in factored form, so we want to see if we can get it in factored form. So, but if you recall the statement I made at first up here, it says that we want to take and, let me change color here. We want to put our expression, we want to set it to 0, and then we want to factor to solve. So you can see it's not set to 0 here, so we've got to get the 14 on the other side. I'm just going to subtract 14 from both sides. Then I'm going to get x squared plus 5x minus 14 is then equal to 0. So now what I'm going to do is try to factor this polynomial. Now, remember in this set above when we were factoring, this is kind of the easy one, where we want the factors of negative 14 that sum to 5. I'm going to make a simple little table here. So you can see that 2 times 7 is pretty much the easiest guess there. But I need my sum to be positive 5, so the 2 is going to have to be negative here. So we're going to take those two numbers and we're going to say x minus 2, x plus 7. And so when we solved the factoring there, we're just going to say x minus 2 equals 0, or the factor x plus 7 is equal to 0. And that would then give us, adding 2 to both sides, subtracting 7 to both sides, we would get the answer x is equal to 2, a positive 2. Or we would get then x is equal to negative 7. And write that a little bit neater. So we get our two solutions. So our solution would be x is equal to 2 or negative 7. And remember, when you're putting that into Pearson, you're going to have to put the comma in between your values. More than likely, you're not going to have to type in the x is equal to when you state what the solutions are. Okay, I'm going to erase this part here. Okay, now for our next problem, we've got to, again, get all the terms that are, get all the terms on one side. So I'm going to subtract 15x from both sides. And then what I'm going to do is, just like D from number 2 above, I'm going to factor this common factor out, which is 3x, leaving me with a 2x minus 5 equal to 0, and then I'm going to proceed with the principle of zero products. 3x is equal to 0, or 2x minus 5 is equal to 0. Then if I divide both sides by 3, I get x is equal to 0. It's one answer. And then if I add 5 to both sides, and I get 2x is equal to 5, and then divide by 2, I'm going to get x is equal to 5/2 or 2.5. And remember, this is an or solution, so then my solution would be either 0 or 5/2. And I'm going to leave this set, the final answer go there. So now what we want to do in the last one is we want to say that, oh, x is equal to 7 or x plus 6 is equal to 1 or something like that. But it's not conducive to solving because we want to use the principle of zero products, but it could be anything if you have a product that's equal to 7. But once you have the principle of zero products that you see over here, then one of the factors must be equal to 0, and it's easier to solve that way. You don't want to get stuck in all this guesswork. So first thing we're going to do is we're going to distribute the x. So we get x squared plus 6x. And then at the same time, I'm going to bring this 7 over. So I'm going to make it minus 7 is then equal to 0. So now I'm going to factor. We have a trinomial. So we're going to factor the trinomial as 2 binomials. And recall just one quick guess and check here that we could do with this. We have a first and a last that are fairly easy to work with here because x times x. And we need the factors of -7. We could do this off to the side. The factors of -7 that sum to 6. And we could be real formal about this. And we know it's got to be a 7 times a 1 and a 7 plus 1, right? But one of them has to be negative, and it looks like the -1. So we're going to apply that in there. We've got, that should be our factoring. But now what we had to do with this one, remember, we had to distribute the x first, and then we had to bring the 7 over. So, and then we refactored to solve. So we get then x plus 7 is equal to 0, or we have x minus 1 is equal to 0 using the principle of zero products. And we get x is equal to -7. And then we have x is equal to 1. Okay, and so that's the next topic in the final exam review, solving the equations and finding the solutions, where we say solve versus simplify or just factor. Here we actually find the values that make the equation true. I think, given the time, I think I'll do one more problem. An object is dropped from the top of the Woolworth building. The height h of the object after t seconds is given by this equation. H is equal to -16t squared plus 784. Now, the first thing I'm going to do is I want to take a look at the process here, because I want to say an object's dropped from the top of the Woolworth building. Then I want to know what is the height when it hits the ground. So if it's the top of the Woolworth building, you can kind of picture up here, and you drop something down here. It says an object is dropped from the top of the Woolworth building. The height h of the object after t seconds is given by this equation. Well, if it was 0 seconds, that would tell me that the height was 784, right? So this would be 784 all the way up from the top to the bottom, right? So if it gets to the bottom, I'm going to say that the height is 0 on the ground. So it kind of gives you a system that you want to work with, that if I'm going to say that this is 0, then up here it's going to be 784. Okay, so I'm going to leave it have seconds, and it can't be, I guess it could be 784 feet. I don't know enough about the Woolworth building. I could look that up, but I'm going to leave it 784 feet for right now. So h equals 0 is at the ground. So I'm going to take my equation. I'm going to say 0 is equal to negative 16t squared plus 784. And then I'm going to rewrite this as 16t squared. That means I am adding, let me just do this real quick, 16t squared to the right. And I'm adding 16t squared to the left. So now I have 16t squared is equal to 784. And now I think 16 goes into 784 evenly. So I get t squared is equal to 49. So t then is equal to plus or minus 7. And remember that when we take the square root, we would then produce a positive and a negative square root. But it says find how many seconds pass before the object reaches the ground. So I'm starting at the top. I'm going to assume that t equals 0 is here, and that you might have some idea that you could probably go back in time to get a negative time. But in this case, it's just going to be at t equal 7 seconds, the object reaches the ground. Now I'm going to stop this video and pick up with the next problem, number 5, on the final exam review for college math. I'll see you in a bit.